Hi, welcome to my video on evaluating trig expressions if a point lies on the terminal arm of the rotation. Find the exact values of each. Let's do some examples. Negative 6/8 lies on the terminal arm of theta, and we have to find the sine of theta plus the cos of theta. So what I'm going to do is draw a diagram plotting the point negative 6/8. X is right here, y is here, so x is negative 6. Let's pretend is right there. And y is 8. Let's pretend is right there. Don't have to be exact. So the point negative 6/8 is right there. Up from here and over from there. That means I have a terminal arm going through that. And we can have a circle that passes through that point. And this is the radius of the circle right from here to here. So theta is the rotation from the initial arm right around till you get, so there's the rotation. So the initial arm is rotating till it hits right here, passing. So the terminal arm is passing through this point. So we drop a perpendicular to the x-axis, hitting at negative 6. And that means this length right here on the x is negative 6. And this length on the y is 8. X is negative 6, y is 8. And we have to figure out what the Pythagorean property is. Because a squared plus b squared is c squared, but in a better way is r squared is x squared plus y squared. So r is the hypotenuse, x is negative 6, y is 8 being squared. So r squared is 36, 64. R squared is 100. So the square root of r is an r. Square root of r squared is plus or minus the square root of 100. So r is equal to plus or minus 10. So the radius is always positive. So this is 10. So what we have, the sine, and we know, or should know, and I have this right here written down right now. I'm going to just show it to you instead of writing it out all the time. Notice I have SOHCAHTOA. Sine is opposite over hypotenuse, cos is adjacent over hypotenuse, tan is opposite over adjacent. Sine is the y over the r, the cos is the x over the r, and the tan is the y over the x, and cosec is the reciprocal of sine. So it's r over y, sec is the reciprocal of cos, so it's r over x, cot is x over y, reciprocal of tan. So keeping that there, that's as a reminder. So the sine of theta, so remember it's in terms of the reference angle, the angle that's in this corner. And so sine of theta is, sine is the y, which is the 8 over the hypotenuse. So it's 8 over 10. The cos is the x over the hypotenuse or the radius. So x is negative 6 over 10. And we can reduce them or we can subtract them right now. So common denominator is 10. So 8 add on negative 6 is 2. And 2 over 10 is 1/5. And the tan times cos, we're going to use the same triangle with the reference angle, even though theta, just a reminder, theta is this rotation from here right around to here, is the reference angle that's in this right triangle that determines what numbers we're going to use. So tan is the y over the x. So bring that down. Tan is the y over the x. So it's 8 over negative 6. And the cos is the x over the r. So it's a negative 6 over 10. And we reduce if we can. So the negatives cancel out, and we get 2 into 8 goes 4, 2 into 10 goes 5, so we get 4 over 5. We could multiply these fractions by multiplying, but it's better to cancel first and then multiply after. C, we got 12 sine squared theta. So that's the sine of theta being squared. And the sine is the y over the radius, so it's 8 over 10. And so because we have the squared, it's best to reduce the 8 over 10 to 4 over 5 first. And now we obey PEMDAS. We have the square first, that's 16 over 25, and that's over 1. And they can't cancel. So therefore, we get 12 times 16. And we pick up our calculator, and we just multiply 12 by 16, and we clear. Just hold on for a second now. I'll move out of this. Let's turn it off, and we turn it back on. So we're getting 12 times 16, and we get 192. So we get 192 over 25. D, the tan of theta, bracket, cos of theta minus sine. So let's put each of these in first. So the tan, we worked it out here to be 8 over negative 6. And the cos, we worked it out to be negative 6 over 10. Subtract the sine. The sine is 8 over 10. What you work them out once, you look back here and see them. Now we have to work out the inside of this first, but we'll simplify this fraction here. So that's a negative 4 over 3. The negative never goes on the bottom. And this is, we're adding on the opposite. So that's a negative 14 over 10. So negative 4 over 3 times negative 7 over 5. And now we cannot cancel. So we, negative times negative is positive. 4 sevens are 28 over 15. Notice in PEMDAS you have to work out the inside of this first before we multiply, and that's what I did. But don't forget to try to remember to reduce your fractions. Okay, let's try some more practice this time. And again, I have this sheet here, but I always need to draw the diagram. Diagram is very important in setting it up. The point 5, negative 12 lies on the terminal arm of alpha. So 5 is here, negative 12 is down here, so that's 5 on the x, and that's the y, so there's the negative 12, so this point is right here. So this is the point 5, negative 12. Terminal arm goes to that point. So the circle goes around like this. And we drop a perpendicular to the x-axis. Always to the x. Never put a perpendicular to the y. So the x is 5 and the y is a negative 12. And we work out the radius of the circle again, which is right here. So r squared is x squared plus y squared. And so the r squared x is, as you can see, x is 5. And y is negative 12. So r squared is 25 plus 144. R squared is 169. R squared is, the square root of r squared is plus minus the square root of 169. So r, I better not square it. Square root of r squared is just r, plus or minus 13. So r is equal to 13. So we put a 13 here. And we work out the tan. And again, bring this into play. Tan is the y over the x. So the y is in terms of this angle. This angle is the reference angle. That's the reference angle in this corner. That's what determines the opposite, adjacent, and the hypotenuse, this reference angle right here. Oh, and just explain, alpha is the rotation from the initial arm. So that's the initial arm that's going around starting here. So alpha goes all the way around the circle. There it is, all the way till you get to the terminal arm. So that's the rotation of alpha. But to work out the numbers, the sides, and that, we have to use this reference angle. So tan is up, is the y over the x. So that makes the y is the negative 12. And the x is 5. And the sine is the y over the r. So that's a negative 12 over r is 13. And we work that out. So we're dividing fractions. So it's a negative 12 over 5 times 13 over 12. Negative goes on the top. The 12s cancel out. Negative times a negative positive. So 1 times 13 is 13. And 5 times 1 is 5. So 13 over 5 is the answer. And number 2, the point negative 1 root 3 lies on the terminal arm of theta. And again, always draw a diagram. It's easier when you draw a diagram. X is negative 1, so let's pretend that that negative 1 is right there. And y is root 3. Root 3 is, let's say right there. Root 3 is, what is the square root of 3? I don't memorize it. Of all the times the square root of 3. Let's check the square root of 3. The square root of 3 is 1.7. And let's do the square root of 2. And square root of 2 is 1.4. Okay. So we're just going up this distance of, so the point that we're talking about is negative 1 for the x, root 3 for the y. There's a terminal arm that goes to this point, and there's a circle that goes around with a radius. There it is, there's the radius. We drop a right triangle to the x-axis. So x is negative 1, and y is root 3. And we work out the radius or the hypotenuse. So r squared is x squared plus y squared. And r squared, x is negative 1. Y is root 3, and we square them. R squared, negative 1 times negative 1 is 1. Root 3 times root 3 is 3. R squared is 4. So the square root of r squared is plus minus the square root of 4. R is equal to plus minus 2. So the radius is 2. And so we have root 2. Tan is, bring in our sheet, tan is the y over the x. So the y is root 3 over x, which is negative 1, 8 root 6, and cos is the x over the r, so the x is negative 1 over r, which is 2. So we have them simplified, or should I say put the values in. And so we can't cancel here, so that's root 2 times root 3 is root 6 and is negative. And this is going to be a negative. 2 cancels in 8, 4, so that's a negative 4 root 6. And a negative 1 root 6 and a negative 4 root 6 is a negative 5 root 6. Fully simplified. And we'll continue. So you can see the pattern that I'm establishing. You should draw a diagram, and normally when you do that, you don't go wrong. Hopefully you don't go wrong. And number 3, we have same thing again, only we're practicing. Practice means pause the video and work the answers out. Here we go. Draw a diagram. And we have an angle rotating. So the point is x is negative 3 right here. Y is negative 4 right here. Negative 4, negative 3. That's the y-axis. That's the x-axis. So there's the point. -3, -4. Terminal arm goes out to that point. And there's a circle that goes around like that. And that's the radius. And perpendicular is drawn to the x-axis, never to the y. So the x is -3, the y is -4, and we work out the radius. R squared is x squared plus y squared. R squared is -3 squared and -4 squared. R squared is 9 plus 16. R squared is 25. Square root of r squared is plus minus the square root of 25. So r equals plus minus 5. Radius is never negative, so it's 5. So that's a 5. And cosecant, well, bring in cosecant is the reciprocal of sine. So cosecant, secant, S, so I need a C. So secant is the reciprocal of cos. So secant is the r over the x. So the radius is 5 all over the x, which is -3. Subtract cosecant, the reciprocal of sine. Sine is the y over the r, so cosecant is the r over the y, which is the 5 over, and the y is a -4. So we simplify that, so that's a -5/3. Double negative is a positive, is 5/4. Common denominator is 12, so we multiply the first one by 4/4, second one by 3/3. -20/12, add on 15/12, that's a -5/12. And remember, don't forget, pause the video and work this out before I do. And cot, this is cot squared, so let's work out what cot is, and then we'll square it. So the square is here, but we put the square outside the bracket. And tan is the y over the x, so cot is the x over the y. So the x over the y is -3/-4. That gives me 3/4 squared, so that's 3 times 3 is 9, 4 times 4 is 16. Done. And we'll figure out what tan times cosecant plus secant and beta. Oh, I just forgot them. The point is right here. So beta is from the initial arm here. So this initial arm is rotating, and it's rotating all the way around. There's the rotation for beta. So that's beta. But the angle that we'll work out from is what we call the reference angle. That's the angle that's in this corner right here. This is the angle that determines all the fractions, all the ratios. And tan is the y over the x. So tan is the y, which is a -4 over the x, which is -3. Cosecant is the reciprocal of sine, so it's the r over the y. So it's 5 over the y, which is -4. And secant is the reciprocal of cos. Cos is x over r, so secant is r over x. So that's 5 over -3. 5 over -3, and we take our time. We have to do PEMDAS. We have to multiply first, so the -4's cancel out. So that gives me -5/3. Add on, and that's a -5/3. Negative never goes on the bottom. Common denominator is 3. So we add, we get a -10. So -10/3 is the final answer. And again, it's imperative that you remember on a circle that you write what I do when I was learning this as a student many, many years ago. I kept this in my head. I wrote it down until I knew what I was doing. And you never go wrong. Never, never go wrong. Now, number 4 is practice. But this time, we have the point 6, -8 lies on the terminal arm of theta. And the terminal arm of alpha passes through this point. So I got 2 rotations. So I'm going to go down the bottom down here and work out This is the rotation for theta, and this is the point 6, negative 8. X is 6, y is negative 8. So there's 6, there's negative 8. So that's the point of 6, negative 8. Remember, that's the x, and that's the y. So there's the point going through that terminal arm going through that point. So here's the radius. And theta is the rotation from the initial arm. There's the initial arm right there, right from the origin 0, 0. So we rotate. There's the rotation of theta on the circle till you get to that point. So that's the rotation of theta. As you can see, it's 90, 180, 270, and it's more than 270 if you want to look at degrees. So we drop a perpendicular to the x-axis. That means the x is 6, the y is negative 8, and we work out the reference angle that's in this corner. And so we get r squared is x squared plus y squared. So r squared, x is 6, y is negative 8. So that's 36 plus, as a square, 64. R squared is 100. So let's go over here. The square root of r squared is plus minus the square root of 100. Square root of r squared is r, plus minus square root of 100 is 10. So the radius is 10. So we got that one done. Now we have another one. We have, this is theta, rotation. Now we have alpha. So we have a point, x is negative 12. Let's pretend the negative 12 is right there. And 5 is up right here, because that's the y, and that's the x. So this point lies right here. So that's the negative 12, 5. Terminal arm goes out to that point, and we draw a circle. This is the radius of the circle, and extend his arm out. So there's the initial arm right there, and it's rotating till you hit that point, and that's alpha. And so we drop a perpendicular to the x-axis. X is negative 12, y is 5, and we work out the radius. So r squared is x squared plus y squared. So r squared is x is negative 12 squared plus y is 5 squared. R squared is 144 plus 25. R squared is 169. The root of r squared is plus or minus the root of 169. So that means that r is plus or minus 13, which is the square root of 169, so the radius is 13. Okay, now we have to be careful. So we have to fill in this one. So what I do is I fill them in first. And there's my sheet I keep track of. So I'm going to do theta first, because this is the first diagram. The cosecant of theta. Cosecant is the reciprocal of sine. So sine is the y over the r. So cosecant is the r over the y. But I have to look the r, which is 10, over the y, which is negative 8. And again, it's in terms of the reference angle. And I got theta here, cot. Tan is the y over the x, cot is the x over the y. So here's theta again. X is 6 over the y, which is negative 8. Now I have to do alpha. I do theta and then alpha instead of jumping back and forth. And remember, this is the reference angle that you determine your ratios. I do the cos. Cos is, and I have this cos is the x over the r. So I have to take x, which is the negative 12, over the r, which is the radius, which is 13. And I have secant. Secant is the reciprocal of cos. So cos is x over r. I have r over x. So r is 13 divided by x, and the x is the negative 12. So I have them filled in. Now I have to multiply and divide first, but I'm going to do this negative 12 over 13, and this is a negative 8 over 10. I'm going to do this as a negative 6 over 8, and I'm going to divide, so I'm going to multiply by the reciprocal, which is the negative 12 over 13. Okay, so notice I have to I have to multiply these two first, and then I subtract last. So can I cancel? 10, 2 into 10 goes 5, 2, that's 6, so that's a positive 6 eighths or 48 over 13. And this is that's a negative times a negative is positive. So 2 into 6 goes 3, 2 into 8 goes 4, and 4 into 12 goes 3. So I get, notice it's a negative times a negative positive, so I get 9 over the 4 canceled out, 9 over 13. So that gives me a common denominator of 13. 48 minus 9 is 39 over 13 is my final answer. So notice we had two rotations, so I did two different diagrams. Just be careful, and then we had to put them together. And again, memorize this. SOHCAHTOA, sine. Sine is the y over the r on a circle. In a right triangle, sine is the opposite over hypotenuse. But when we're dealing with a circle, we have y's, x's, and r's, and learn this. I have this down pat. I just write it down on a sheet of paper. And when you're doing trig, you got to keep that in your head. I write it down, so when I need it, I don't have to keep going over and over and over. And that brings us to the end of it. If you like my video, click the like button, subscribe button, notification bell. Visit my website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.